Hi, I'd like to talk about comparative planetology. This is the method of studying different planets by comparison. And I'd like to speak about comparative planetology of the inner rocky planets. But first, let's look at the solar system and how its mass is divided into different parts. Almost all of the solar system, 99.8%, is in the sun. So when the solar system formed, most of the material fell by gravity and formed the sun. Most of the rest of the material, at least half of the rest of the material, 0.1, so half of what's left, 0.1% formed Jupiter. The other giant planets, well, about 0.04%. And the rocky planets and the dwarf planets, so this is the topic of this video, are 0.001% of the mass in the solar system. Comets, well, that's considerably unknown in terms of how many comets might be far out in the solar system, but comets, rings, and moons, and asteroids all comprise even less in terms of the total mass. So, when we think about these outer planets, Jupiter, Saturn, Uranus, and Neptune, compared to the size of the Earth, we see the Earth is much smaller and as I said, much less mass. And so one thing though is that the density of Earth is significantly higher. And so because it's a rocky planet with an iron core, when you compare that to these which have sort of more rocky cores with vast amounts of gas and water, especially in the cases of Uranus and Neptune, and hydrogen in the cases of Saturn and Jupiter. So these are very low density, so there's a lot of mass spread out over space. This is a higher density planet, but still all of these are much more massive than Earth. So if we want to compare that to the inner planets, we see here now the Earth is here, Venus is here, and Venus has a little bit less mass than Earth, and then we have Mars and Mercury with considerably less mass than Earth. So a couple of things in terms of comparative planetology of these. The Venus and the Earth both have thick atmospheres, although Venus's atmosphere is about 90 times the pressure of Earth on the surface. And this is because Venus has lost a lot of its interior gases, and Earth has water, has oceans. Venus does not. And Venus has even water inside the mantle inside the Earth. Venus may not have as much of that. So a very thick atmosphere, carbon dioxide. Earth's atmosphere is moderate to thick. We have nitrogen as mostly in our atmosphere, and oxygen is second, tiny amounts of carbon dioxide, and we also have tiny amounts of water vapor and traces of other elements. Now Mars and Mercury is just too small. Mercury has no atmosphere at all, and there's some atoms that sort of hang around near the surface, especially after being bombarded by the winds from the sun and the radiation from the sun, the light intense light from the sun. Mars, on the other hand, has a thin atmosphere. You can see maybe in this picture a little glow around the edge, a very, very thin atmosphere, much, much thinner than Earth's atmosphere, of carbon dioxide almost completely in its atmosphere. So the only one of these that has surface water is the Earth, although Mars has polar caps, ice on the poles. You can see the southern pole here. The Earth does as well. Venus does not. The Earth has clouds. Venus is covered by clouds. This picture is not showing Venus. It's showing the surface. It does not show the cloud cover that is usually completely covering Venus. Mars has occasional clouds, especially up near the volcanoes. And we don't have clouds here on Mercury. We do have ice at the bottom of craters on Mercury that are at the north and south poles. So if we look here at the masses, we can see the huge difference. The Earth is 1, Mercury and Venus. Venus, 82% the mass of Earth. Mercury, only 5%. Mars, 11% the mass of Earth. However, the outer planets, Jupiter, 318 times the mass of Earth. Venus, Saturn, 95 times the mass of Earth. Uranus and Neptune, 15 and 17 times the mass of Earth, respectively. So that is a comparison of the masses. If we look at the densities, we can see all of these inner planets have very high densities. Mars is a little bit lower. The highest density planet is Earth. Mercury has a very high density because it has a large iron core. Earth has a larger density because it has more mass and compresses the entire planet. Mars is a bit lower, about a little bit more than the density of rock. So there's probably an iron core with a mantle and a rock crust. But the outer planets all have very, very low densities, much closer, all much smaller than the density of rock. The density of rock is about 2 to 3 times the density of water. All of these are between the density of rock and water, except Saturn has a lower density than water. So we can see that there's a big difference between the masses and the density of the inner planets and the outer planets, and that's due to the composition. The inner planets are made of rock with iron cores, and the outer planets are gas or ice giant planets. The 4 inner planets are the only rocky planets in the solar system. The 4 inner planets are composed of iron cores with rocky mantles and crusts. They are more dense than the giant planets. Also the moons. Unlike the giant planets, the rocky planets do not have rings and not many moons. No moons for Mercury and Venus. Earth has 1 moon that we call the moon. Mars has 2 moons, Phobos and Deimos. And if we look at the amount of the inner rocky planets, Mercury, Venus, Earth, and Mars, and the moon is here too. So about half of all of this rock and iron, about half of the mass of all of these is in the Earth. Second, Venus, and Mercury and Mars and Mercury and the moon all have substantially less. And so finally and briefly, looking at the core, we see each of these have a core, and we aren't really sure about the moon, and they have a mantle in between the core and a crust. Mercury has a very large core compared to its crust, and not really any mantle at all here. Venus has a mantle and Mars has a mantle and very thin crust